Yeah, g'day, Ken Smith here. Look, one of my passions is fixing up old German vehicles, and recently I've been working on this old Porsche 356A. I've learned a few lessons along the way, particularly, well, at the moment, in the front suspension department, there's been some traps. So this vehicle was completely misused through the 50s and the 60s and the 70s, and spent some time on a racetrack, and it was completely mistreated. When I got the vehicle, I put it up on the hoist and I discovered that one wheel on the front would move up and down quite easily, the other did not. It was, the front suspension was shot basically, so I pulled it apart most of the way. What I found was the Porsche front torsion bars had it. They're delaminated and you can just see they're horrible, okay? Those torsion leaves are shot. So the challenge is no one can provide new torsion bars for the front of one of these things. What I did discover is the Volkswagen torsion bar used up until about 65 for the old link pin, kingpin suspension system is nearly the same except for a couple of drillings. For example, a Porsche has the centre drilling there, and the end of the link arms, the trailing arms, secure there with a screw. The Volkswagen, they're all on the one side. Okay, there's a problem there. I don't want to drill the Volkswagen ones from the other side while there's an existing Volkswagen hole. It reduces the net section, and I'm a little bit concerned about failure and cracking and the whole thing falling apart when I'm halfway around a corner and there's a tree in the road, the suspension arm comes off, because these also restrain the suspension arm. So what I did is I bought several sets of Volkswagen torsion bars and I pulled them apart because they were only drilled in the centre. So here's a whole heap of leftover leaves here, and they're to be discarded. Now these are brand new Volkswagen ones. They're stamped Volkswagen. They were made in Brazil, but seriously, it looks like they were put together by a butcher. So they're to be thrown out. The ones that escaped drilling, because their procedure was pretty shoddy, I managed to keep here, and I'm going to drill these to the Porsche pattern, and and you know what? I'm going to have brand new torsion bars as good as. So once I've had them welded on the end, I can put them in a jig, drill them, and I'm in business. What was also shot were the bearings that support the trailing arms at the front. So one of the challenges I had is the original Porsche bearings, there's one there, they're no longer available. Now they're a 45mm OD, they're 52mm nominally on the, 45mm on the ID. The OD is around about 52mm. There are replacement bearings available from some Porsche shops. They're not cheap. I've seen them for sale around about $35 US. Trouble is, you don't get 4 as per the original bearings. You've got to get 8, so the cost gets out of hand pretty quickly. I did a bit of research, and what I found was those bearings needn't be bought from a Porsche specialty supplier at $35 US a piece. I found them. I bought these from Consolidated Bearings here in Australia. Now, you might want to write this down, as Bette Midler said. The brand is INA. You'll see they're thinner than the normal Porsche bearings. That's why you have to use 2. You double them up. You'll also see the Porsche bearing has a flange on the end, which these ones will not. That's okay. Porsche, in their wisdom, have catered for that eventuality by manufacturing a spacer. If you're to use these new bearings, you've got to use them in conjunction with that spacer available from Porsche. So the Porsche part number for that is 695 341 10801. So you can get that. You'll need 4 of them. You'll need 8 of these bearings. INA, stamped INA, they're also made in Germany. Germany stamped on the side of them. Now these are important. I got those for $11 Australian, I think it was, which is significantly less than 35 US. So write this down. The number is HK4520-B. Give that number again, HK4520-B. INA is the brand. So far I've managed to sort out the torsion bar issue. I've got the bearings sorted at a fairly low cost, really, compared to what I would have paid if I'd bought from a specialty supply house. Now, of course, the inner part of the front trailing arm is supported by a micarta bush. Now micarta is like a Bakelite resin with fabric reinforcement in it. I've got some VW ones here. I fear that they're going to be too small on the outside diameter. You insert them and you ream them to size. I don't think they're going to do the job. I did a bit of research. By the looks of it, the Porsche one is, well, it sort of brackets 46 millimeters. This one's 45.5, so maybe I'll have to save those when I buy an old bug sometime. Right, so torsion bars, inside bushes, outside bearings, spacers. We're nearly ready to go. Now what you'll see is that I've managed to get that bearing out. That's a challenge. There is a special Porsche tool required to extract that bearing. Almost nil stock everywhere, haven't seen one in years. However, I've made a tool. And I'd like to share that with you. So what I've got is a piece of 12mm thread bar. Length's not really important. 2 nuts, like that. Now I made that steel pivoting puller. So the plan is, I've drilled a hole through the middle. I think it's around about a 15mm hole I drilled through for the 12mm rod. I wanted it a little oversized. And you'll see that I've also filed a lead in angle and a lead out angle. And the reason I've done that is when I put my tool over my thread bar, I'll explain how it works in a minute, slides over like that. I want this to be able to tilt so it fits through the bearing and then stand up straight when I pull it back with a slide hammer on the other end. So you'll see the lead in and lead out angles allow that to tilt a bit more. It doesn't tilt so much that way where I haven't filed it. So without any further ado, I've left 2 bearings in there. We might pull one out and I can show you how it works. So thread bar, there's my piece of steel. Now you'll see that that's 40 on there, that's 51.94 mil, so close enough to 52. Depends on how you spin it. It's a little bit bent after I pulled it out. Of course, won't be any good after I've pulled it out. This one, 51.25, and I've radiused it to suit the end of the bearing, so it'll slip through. At the back of the bearing, it'll stand up straight. I can put my slide hammer on it and knock the bearing out. Right, so that goes on there. In order for the slide hammer to work, I've got this piece of steel over here. Probably weighs about 6 kilos, I guess. It's actually the weight off a conveyor pulley, but it's conveniently got a hole through the middle that I didn't have to drill, and the bar fits right through. So I've got my pivoting pulling bit on the end, slide that through, nut on the other end, and we're in business. So we'll just go around to the other side of the car. Oh, that hurt. Pull that off. So, tilt that. Slide it through. I can feel the bearing there. That's the flange that we saw on the other bearing. That way. Okay, it stands up straight. And bearing comes out very neatly. Okay, we'll sign off there, and we might make another video if there's more to learn later on. Cheers.